Good day, class. Let's begin our discussion of Chapter 3, where we look at two individuals, Lakatos and Firebrand. First, Emery Lakatos. What he sought to do was to improve Popper's insights. He disagreed vehemently against Kuhn's ideas. Kuhn's rejection of falsification and proposed scientific revolution, he saw this as being too simplistic and irrational and led to mob psychology at times. What Lakatos sought to do was to seek a rational grounds for theory change. Falsification, nothing can be proved to be true, but can be proved false. He sought a goal to develop a sophisticated form of falsification. On Popper, Lakatos viewed Popper as a methodological falsificationist. The scientific community decides to falsify. Once rejected, but it can be, according to him, reinstated. What Lakatos sought to do, additionally, was to not just look at theory testing, comparing theory to observations. Recall with Popper, when you had data from your observations that went against your theory, well, that was grounds for falsifying it. Theory testing, comparing theory to observations, is good, but it also should include comparing to other theories. This addition is what he referred to as a research program. Falsification only when a better theory predicts new findings to take the place of a rejected theory. Note again that with Karl Popper, there was no such thing. There was no such thing as having to say we can only falsify this theory if we have another theory to replace it. That was not part of his process. So, flexible on the rules on when enough falsification has occurred to reject a theory. So, Lakatos's focus. We see that he constructed the book, A Methodology of Scientific Research Programs. He synthesized Popper and Kuhn together by focusing on a research program. So he was trying to bring these two disparate ideas together. A research program is defined as a series of theories sharing a common hard core of assumptions. Following Popper, Lakatos also emphasizes falsification, but believes this only happens following Kuhn's guidance when a better theory emerges. He argued science was a progressive falsification of theory. So let's look at comparing what Lakatos's view of falsification and then Popper's view. So, naive falsificationism is that a theory is falsified by an observational statement that conflicts with it. More of what we see with Karl Popper. A theory is falsified when the data from some sort of observation or experiment conflicts with the theory. From a sophisticated falsificationism perspective, it attempts to do a better job of accounting for scientific progress than this original version of falsificationism. So, replacing the theory. A theory that is shown to be inadequate is replaced by a better one, but typically one which belongs to the same family. We have a sequence of theories: Theory 1, T1, Theory 2, T2, and T3, and so on, each of which explains more than its predecessor and thus supersedes it. Such a sequence of interrelated theories is what Lakatos calls a scientific research program. Specifically, how do we do this? A theory, T1, is falsified if another theory, T2, has been proposed with the following characteristics. T2 has excess empirical content over T1. That is, if it predicts novel facts. So T2 predicts novel facts, T1 does not. T2 explains the empirical content of T1. So everything that T1 can explain, Theory 2 also explains that. And some of the excess content of T2 is corroborated, so it has support. So these are the characteristics. T2 has excess empirical content over T1. It explains all the content of T1. And theory 2, the sum of the excess content of theory 2 is also cooperating. So there's other observational data that supports it. Thus, no experiment, experimental report, observation, statement, or well-corroborated low-level falsifying hypothesis can lead to falsification. The idea here is this. Lakatos is trying to make it more difficult to falsify a theory. In essence, what this suggests is that Lakatos believed that Karl Popper and his perspective of falsificationism was too abrupt, that a theory could be falsified too easily. So he wanted to put the brakes, so to speak, on the ease of falsifying a particular theory. So there is no falsification before the emergence of a better theory. Unlike Popper, Lakatos proposes a sophisticated falsification view. Unlike Kuhn, Lakatos argues for an objective criteria of progress, the prediction of new facts, not subjective factors. Remember, going back to Thomas Kuhn, he wanted to look at how science actually gets done. And what he proposed was science gets done based on the people, the scientists who are doing the science. And sometimes that leads to subjective factors. That subjective factors has a great deal of influence and impact on science. This irrationality. What Lakatos is attempting to do is to get away from those subjective factors. For Lakatos, a research program is defined by its key assumptions. These form the hard core of the scientific research program, the SRP. This hard core is protected by a negative heuristic, the rule that forbids scholars working within the scientific research program from contradicting the hard core. So basically, what this is saying is this. If you're in this research program, there's going to be a set of beliefs that cannot be contradicted. A set of beliefs that we hold sacrosanct. A set of beliefs that we do not touch. So this hardcore is protected by a negative heuristic, the rule that forbids scholars working with SRP from contradicting the hardcore. To deal with inconsistent evidence, Lakatos argues that SRPs develop a positive heuristic or a protective belt of auxiliary hypotheses. Such auxiliary hypotheses can include additional assumptions or restrictions on the scope that make the theory consistent with observed facts. So at the center, you have the hardcore that we do not touch. We don't violate any of the things that the hardcore statement suggests. But around the hardcore and this protective belt, we have things there, hypotheses and other items that can be massaged in order to make sure that our theory remains consistent with the facts that we are observing in the real world. So in this way, one could suggest that this is roughly equivalent to what Kuhn referred to as problem solving. The idea that, again, with the paradigm, according to Kuhn, that all scientists work under, they share same paradigm, but the paradigm is not about breaking the paradigm or destroying it. You work within the paradigm. So from Lakatos' point of view, this is a roughly equivalent perspective for the heuristic here of having this auxiliary hypothesis, additional assumptions or restrictions that we can adjust so that the theory still can be valid with the observed facts. So the idea is protecting the hardcore. Whenever observations do not fit smoothly into the framework and objections are raised, the rational response is not to forego the hardcore assumptions because we do not mess with them, but to protect them by a set of auxiliary hypotheses that aim at increasing the predictive power of the program and in this way protect the hard core. So we have things floating around in the protective belt that can be used to explain some confusing data from some experimentation. But we never question the hard core. We leave that alone. So this protective belt, the part of the research program containing the auxiliary hypothesis is thus called the protective belt. It indicates what needs to be done in order to increase the explanatory and predictive power of the program. So this protective belt is there for the express purpose of making sure that we can adjust the things there to fit with what we're seeing out in the world. So the scientific research program, a theory is a rule of logic and mathematics, statements of laws, assumptions about initial conditions. A SRP is a lineage of theories. The scientific research program evolved over time. Rules according to which the SRP evolved over time, well, this is what happens. Two questions: revision versus ad hoc hypothesis. Do we revise the theory or do we add ad hoc hypotheses? Two questions. In the light of anomalies, remember anomalies, things that do not fit with our current paradigm or our current research program. It doesn't fit with our current prevailing theory to which we're operating under. We saw this in previous chapter 2 with Thomas Kuhn as well. So, in light of anomalies, what should one change? Well, we have first the principle of least change. We don't want to change things that are big, we change things that are small. When should one abandon a theory in favor of another? Those are the two questions. What should one change? We want to use the principle of least change. And when should one abandon a theory in favor of another? So, the ad hoc hypothesis. In science and philosophy, an ad hoc hypothesis is a hypothesis added to a theory in order to save it from being falsified. Ad hoc hypothesizing is compensating for anomalies not anticipated by the theory in its unmodified form. So we have the scientific research program here in this graph. And the center, what we've talked about is that hard core. So that black circle in the center with the dots in it, those are the hardcore theoretical assumptions, our metaphysical commitments to whatever this research program is. We do not change these. These things we accept as the true facts of things. And around that hardcore, we have the auxiliary belt. Initial conditions, assumptions, and ad hoc hypotheses go here. Again, it is protective of the hardcore. This belt, this auxiliary belt, protects the hardcore so that we don't have to change our hardcore assumptions, which we do not want to do. The auxiliary belt can have a lot of flux in it. It can change and be modified and whatnot as long as it maintains some sort of logic behind it and maintains the protection of the hardcore beliefs. So let's look at an example from celestial mechanics. So from celestial mechanics, the stuff of the stars and planets and nebulae and things of that nature. So in celestial mechanics, we have as the hardcore things that we do not question, things that we don't debate, things that we accept as the law, so to speak. We have laws of motion, universal gravitation, space and time. So basically, we don't start to make anything up or look at data. We don't change the hardcore beliefs, okay? Because these things are to be accepted. But the auxiliary belt, well, those things can change. Number of planets. A few years ago, we lost Pluto as a planet, so it's no longer a planet anymore. That was part of the auxiliary belt when it comes to celestial mechanics. The number of planets, of course, that can change. Masses of planets may change as well. So the idea is that the core, hardcore beliefs are maintained, but the auxiliary belt can have some flux in it. So as we collect data, we can say this data does not meet what we expected to see. We can change things which would be equivalent to the things in the auxiliary belt, but we're not going to go about changing the laws of motion or saying, well, gravity is different on that planet or affects differently in some manner. So the notion is we have our hard core and we have our auxiliary belt. We are protecting the hard core with that auxiliary belt. So falsifying a research program is what it comes to. So when is a research program falsified? So part of the difference that we see from Popper is that Popper was just talking about theory and observation. Here we're talking about a series of theories, part of a family of theories, a research program. So a research program R1 is falsified when there is an alternative research program R2 that does the following. 1, can explain and predict as much as research program R1 does, and 2, predicts novel facts, some of which are corroborated. So the same basic idea just that we saw previously, just a larger scope. Now we're talking about a research program, not a theory, but a research program, which again is a family of theories. So for Lakatos, as for Popper, the prediction of new facts is central to the concept of science and scientific progression. Contrary to Popper, however, Lakatos, it is not falsification per se, but the ability to uncover these new facts that separate science from pseudoscience. So again, what is science? The theory must be founded on natural laws. Theory must be falsifiable. Theory must produce hypotheses that are corroborated by evidence. This confirmation is overblown. Most research progresses by solving puzzles, using the ideas within the hard core of a research program. Rewards go to those who solve particularly hard puzzles. So, in the conditions of science, predictions of new facts that are then corroborated by evidence is the ideal. Scientific revolutions or paradigm shifts are rare. Challenging or amending the hard core is not what science is usually about. That may be the stuff of science fiction, when all of a sudden we realize that we can bend space and time, but not here. So challenging or changing how we think about the universe occurs at several levels, from resolving particularly difficult puzzles to developing a new paradigm.